Hello, everybody, and welcome back to this Arduboy dev stream. This is the number 40, and I think it's 10 months that I didn't record any stream. So sorry if I if I let you down for so long. Um, all right, and so I will explain what I've done outside of the stream. Not so many stuff. Don't worry. And then we'll try to continue to do some optimization and maybe try to start compressing the map. We'll see. Okay, so last time I left you saying that probably I will try to um, use the draw static collision for drawing the destroyable block. And I told you that I will test that outside of the stream, and if it's okay, I will keep it. So yeah, that's what I did, and I was happy with it, so I just kept it. But now I can show you what I've done. So basically, without any surprise, here in the destroyable block, I add the draw static collision step, in which I draw a specific sprite, right? And also, I simplify it by having just one sprite instead of two. Um, so that leaves some more space for the sprite for all the collision, all the static collision in the wall bitmap. So that means I don't need this anymore, the sprite idea. Okay, so that simplify also this function. So yeah, simplification in the header also. So the image, I just add a new image just to store this destroyable block, which can be in just now it's a separate sprite, so it can be as long as I want, and it can be its own sprite. So just one sprite actually. Which means also in the wall, I could remove it. Um, and here there is empty space now that is free for another sprite, and later I will use it. Don't worry. So of course that I changed the map data to test it, like using the destroyable block. And so in the map manager, yeah, obviously I removed that parameter, no need anymore. Now there's only just one sprite instead of left and right, just one is enough. And yeah, some extra test here. Alright, so here we don't need that parameter anymore. And like I said, that simplified the rendering of the map, the draw of the map manager. So basically, as I told you when I left the stream, I can just delete this whole part here. And actually this test, I just move it here because yeah, we don't need to compute the mirror stuff if we don't have to draw it. Alright, so the sprite data, I just add a new sprite for the destroyable block. Yeah, very simple. And for the header, so we remove these two, and then there's one free space here that we'll use later, and I move the destroyable block at the end. So why at the end? Because remember when the sprite is I told that probably a long time ago, I think. So when all the sprite data is fixed and I'm finalized and happy with the wall, we can actually just remove the last two, or we can remove the sprite at the end, because we don't need them, because they are there's no sprite, so there is no need to just store empty 000 char for drawing 00. We just don't draw it, right? And that's the same for the destroyable block. Now we don't need to draw it. So if I show you the not this image, if I show you this image again, I put the destroyable block at the end, because basically we don't need to. I can just remove that and stop the data up to here, up to the arrow launcher. So everything you don't need to draw, but you want an ID to be to represent something in the map, you can just put this sprite at the end. All right, and yeah, I think that's it. So I can show you the result. Actually, let me restart the game. Okay, so yeah, there is my block here, and okay, and I'm block here also, and I can explode it. So it works as before, but we have simplified it, and we make room for more sprite in the to draw, sorry, the walls and static collision. All right, so next change. I fix a bug for displaying the big statue, and also adjust the small statue image. I'm still not happy with the small statue. Maybe I will change the sprite again, maybe later. I'm not sure. We can, yeah, I think it looks a bit strange, a bit stupid. But anyway, I tried to improve it. And the big statue is still here. So here I put some small statue for testing, and here we have I put some big statue, top, bottom, top, bottom. And in the map manager, so the way it works is actually quite easy. If the sprite we have to draw is a big statue, top or bottom, then I check if the sprite before on the left is also a big statue. So if the sprite, I should do that like this for you maybe, is the sprite before is a statue, then I just mirror it. Because there is, for the big statue, there is a vertical symmetry, okay, a vertical symmetry like this. So the left part of the statue, you draw it normally, but then the right part, you have to draw it mirror. So basically, this sprite, they are not intended to be placed randomly in the map together. They are intended to be placed together, right? So I just add some hard-coded logic, you can say that, hard-coded logic into the draw. Then I don't have to save in the data a kind of mirror flag, right? If I would do a normal game without so much constraint on the memory, probably I would just save a mirror flag, and in the level editor you could just say, okay, this is mirror, this is mirror. Actually, for my Ardulem project, for the Lemmings project, I also have a sprite, and they also can be mirror, And for that project, I saved a mirror flag because I thought it was giving more variety, more possibility to the level designers. But here, I want to save that mirror flag. I know it's just one flag, maybe it's just one bit, but still, we are very, very critical on the space, on the memory space. So I want to save it. That means that's why I use code and I use logic to decide what to mirror and when to mirror. So yeah, if you draw a statue, and if on the left of the statue is anything, okay, just you draw normally. That means it's the left part of the statue. But if on your left it's also the same statue, that means we are part of the big statue, so I can draw it mirror. Right, so that's exactly what I wrote here. If the same sprite but on its left is the same sprite ID, then I draw it mirror. All right, so sprite data, yeah, just a small statue change. So let's see how it looks like. So we have the small statue here. Yeah, I'm still not happy with it. And here we have a big statue, which is pretty nice. I like it. I don't know about you, but yeah. All right. So next, what I've done. Okay, just a bug fix. I just realized that the shiny star was not shining anymore in for the pickup. It's a small bug. So then what I've done, finalize the sprite of the walls. So again, I've changed the sprite of the walls because I had one room, if you remember. But actually, it's I've done more change after that. So yeah, I use the empty space here. I fill it. All right. And I've changed the map to see, to test. And in the map manager, yeah, I just change also the sprite that are mirror randomly. So again, and if you read if you look at that, so basically the first sprite, we just mirror them randomly based on some based on their position, but it could be any kind of stable randomizer, and that gives some variety. And on the or if this is the specific statue, I just like I just said, I just mirror the right part of it, and I will add more code. You will see I will add more stuff like that a bit later. So the sprite, okay, sprite I've changed, and what do we have? So the free space to use, then I use it and I put a second rock. So rock 1 and 2. So that had more variety in the level design, in the art. So let's try that. Okay, so here I have a big area of stones. So yeah, as you can see, there is now different type of stone, and they are mirror or not randomly. So overall, you don't really see the pattern, which I'm happy. It was quite hard to try to break the pattern, because when you have really a kind of grid pattern or diagonal patterns, then yeah. And yeah, we have done that only with two sprite of stones, two sprite of rock, plus the mirror. Of course, the way I've done it is I I make sure that every sprite can be mirror, and when you mirror it, it still get a correct connection with a non-mirror part. So basically, you just fix the pixels around the sprite, and then you draw more or less what you want inside. And this is how you can get a tile set. All right, so next, what I've done. Oops, no, that's not what I want to do. Just want to update. Okay, so next we have, I changed the wall again. So basically I have, okay, yeah, I have remove. So if you remember, there was step, you could have, there is some step, you can create a stair like that. And I had a stair for left and a stair step on left and on right. And I also removed that to only use one sprite instead of two, to also save more more sprite, right? And try to decide about the mirror programmatically again with the same kind of logic. Okay, I just move forward further and further in the same logic. So the left and right, they were here. This is the I don't know what to call it, the left, and this is the right, or the other way around. It's up to you. And so I remove one of them, or I remove the bottom one, and I just move all the sprite up, right? Which leaves room for, finally, which leaves room for the empty space. And that one, we will need it. We will need it, actually. If we want to store the ID of the sprite on only 4 bit, which means 16 ID, then yeah, we had to leave one ID for the empty space, and which was not the case here. Right now, there was still the destroyable block ID here. Okay, so I have again, I have some pixels here, but they are not used. They won't be used. I will cut here. After 14 sprite, I don't care about the rest, but I just leave it here just for me to remember that if you look at the image, this is a destroyable block. All right, and then we missed one. We missed the empty space. So now with this, I can have the empty space ID, and this can fit into 4 bit. So map data, okay. Change again to test the stairs, and okay. So the mirror, how I've done that. Here I just remove the enum, okay, and it's here with no surprise. Still the same logic. So if this is the first rock, okay, we'll randomize the mirror based on their position. If it's the stair, and now I just have one stair, then I just use the same logic as the big statue. I am checking if the sprite on its left is nothing. That means if the so I should, yeah, we'll do it for you reverse. So if the sprite on the stair, if this is the stair, no, if this is the stair, okay, and if the sprite on the stair is nothing, that means this is a stair to go up like this, right? So here there's nothing. Oh yeah, so I should be doing. Sorry, it's very difficult because of the camera. It's reversed, but yeah, if this is nothing, then when you go up, you know that the stair should be like this, right? And if this is the opposite, or maybe I should do it with my other hand. If there is nothing here, then the stair should go that way. Which means, again, on the level design, a designer should not place a stair and a block or a rock here, which actually doesn't make sense. Yeah, if you have a stair step, that means here you have nothing, right? So detecting where is the nothing, you can decide where is the orientation of the stair. All right, so so that, and you can see it's not a lot of code. It's just few bytes of code, right? But it can save us one space in the big data, and it will save a lot of memory when we store the map. All right, so again, updated the sprite, and you can see the header. So now the two left stair, right stair become just stair, and now we have room for the nothing, for the empty space. So let's test it. So I don't know where I put some stairs over there, probably. Yeah. Okay, here. So here you can see, yeah, the stair on the left and the stair on the right. All right, so yeah, so I was quite happy with this. Also, it's a good preparation for the whole for storing the whole map. Good optimization, and I'm happy with, actually. So next we have, okay, so next I just realized something that before I didn't realize by discussing with a friend of me. Yeah, I just realized that the Arduboy, the Arduino processor is a 8-bit processor, which means every time you want to do an operation on int, for example, which is 16-bit, or even a long, which is 32-bit, then the compiler has to generate more instruction just to end on, because the processor only can do an addition on a char on 8-bit in one operation, in one assembly operation instruction. So in one instruction you can do it on a char, but if you use an int, then maybe it has to store data elsewhere, and that generates more instruction for the processor, right? So basically, using int in the code is not that free. Could generate more instruction than using char. If you use an int where it is not necessary to use an int. If you use an int, like for example, for my test, if you use an int on a for loop, for example, that is just iterating on few numbers, then usually the compiler is smart enough to actually convert it to a char, just 1 byte, and then writing for int I or writing for char I is the same. The compiler is compiling the same. But if you do some operation, like for example addition, multiplication, with the iterator or the I variable inside your loop, then maybe the compiler doesn't see what you are trying to do and cannot optimize, and then it may generate more code than what actually is needed, right? So I have went through the code and tried and make some tests and see if there's could be some simple optimization, like replacing some int with a char and checking the memory size. So here you can see that the current size of the program is 26,400 bytes, right? And then I have remove some int. Let's see, what's that? Oh yeah, this one doesn't change anything. This one is usable, but I keep the change, just in case. This one doesn't change, but the next one. So I remove some int from the function. So for example, search for a pixel color along palette array. I was passing an int, but actually the color is just a char. It was just a lazy programming here. Right. And here, but just by changing this variable, actually that saves some bytes. Yes, yeah. I just changed that, and then you could see that because here there was some comparison with this, I could save some bytes. So it's the same here. Basically change the ID can be just a char. So the position x and y, the wall position, is still an int, as we have discussed that many times, because I want it's the wall position on the total large array. Yes, there is some other way to do it, like we could store the coordinate local to the screen, x and y, plus store another char for example, the ID of the screen, in which screen I am. That's true, but that brings so many other difficulties or programming difficulties for the continuity between the screen and stuff like that, and that we will have to deal with. And all that code that is headed to deal with, it's not that sure that we could save. That could be less than the code that the compiler is added just to handle the int x and y. So right now I didn't change the x and y type. It stay int. We'll see later if we need more space or whatever. But here I was just changing the very easy variable that had no reason to be int, but just my laziness, I coded as a int. So here, just I did it mainly on the all the items. So I went through all the items and check it. Here, for example, the shake x for the stalactite, shaking a bit. The shake is sorry about the noise. The shake is coming from this array, which is as you can see 1 minus 1 2 minus 2. So it can't be stored on a char, definitely, and then it given here. That save also. This one also saves some bytes. Alright, so let's compile that and see how much do we save with that. So it's like 26,400. Let's compile it. And this is 26,360. So we save 40 40 byte. 40 byte, that's not a lot, you may think, but it's still quite a lot. Believe me. Why? Because you will see I've tested, not test, I've tried to estimate the size of one screen, the map data of one screen, and I think one screen will be around 50 bytes. Right now the maximum, right now I think it's 126. It's like 16 sprite by 8, right? 16 by 8. So we can let me see, 16 8, yeah, 16 by 8, so it's 128, but we can divide this by 2 because we will store the ID only on 4 bytes, right? So the maximum is will be 64, right? But we have I have another compression idea that I will probably talk about, and that will probably reduce to 50 for one screen. So here we just save 40, so we almost saved one screen, one puzzle screen, right? So it's not that useless. It's not that useless. We should be careful. We should chase any byte we can. All right. So the next is I've done even more optimization. This time for kind of int in the for loop, and some was doing nothing, but some was actually improving the number of the size of the program, like this one, for example. So yeah, I think that was this one. Yeah, because there's a plus operation here, so it was doing a plus on int, but if you just do it on a char, it's cheaper. I think that one was cheaper. Let me check this one. Maybe this one was useless. Yeah, probably this one is a kind of useless, actually. Doesn't change. This one. This one. Yeah. Yeah. Okay, this one and this one. All right, so let's try to compile that to see how much we saved. So right now we had 26,360. And now we are 26,330. So 30 more. So from the beginning, it's like 70 bytes saved. So yeah, definitely we saved one screen, one puzzle screen, just by doing that. I didn't went through all the code, so maybe we can do that. So I have finished to explain what I've done outside of the stream, as you can see. Yeah, maybe there is some more to optimize in the, for example, in the rig. So like I said, okay, XY, we cannot really change it, center XY. But yeah, maybe there is some for loop that uses int in rig also, in the other code also. So, but I may do that in outside of the stream because it's kind of boring optimization. All right, so now what I want to do is try to compress the data. I hope we can try to do that today. And let me explain what I would like to do. I was Not sure exactly how I wanted to do. Um, for sure, I was yeah, I knew about the packing two sprite ID on one char, just using 4 bit, sorry. But um, except from that, I was not totally sure if I could use something else. Um, but yeah, of course, we can do some kind of RLE compression. So the RLE compression is good when you have a kind of pattern that can repeat itself. So basically, the way you do it is, for example, here you see you have many 256, 255. So the empty space is repeated, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So instead of writing this 11 ID, you can just write 11 and then the ID, for example. So you can the simple RLE compression could be like this: you write the number, how many there is this ID, and then you write the ID. Or the opposite, and could be you write the ID and then you write how many times this ID is repeated. Right? Then you go to the next one, like for example this ID, and maybe this ID is only repeated one time. Then you go to the next ID, and yeah, maybe this one is repeated twice. Right? So if you do that, then you can really compress those area. Right? But if you do that, then you probably need to use 4-bit for the sprite ID, and probably also use 4-bit for the count, for the number, how many you use, right? And this works well for this, but if you have just one sprite, then another one different, if there is no repetition in the sprite, then you don't save space. You actually your compression is actually making it bigger, right? So the worst case scenario is in that situation, like ID, and there's only one ID, there's only one ID, there's only one ID, there's only one. Actually, this 111 is repeated all the time, and it just used 4-bit for nothing. You wanted to pack it, all right? So looking at the level design we have, I think so. Let's look at it. You can see that we have a lot of white space repeated, but not so often some space that is some other sprite that is not repeated. So my idea here is to make a kind of a compromise between the both method, compression and not compression. And what I want to do is to only compress the space, right? So basically what I mean is, if the sprite, I just described the sprite ID, just one sprite ID, but if the sprite ID is the space, then the next number is the count, all right? If it's not the space, then the next number is just another sprite ID, right? So I only treat the space as a specific case. And why the space? Because basically the main character, is mostly using the space to navigate through the level, right? If there is no space, I mean, if it's very, yeah, for sure you can create a level that is with a lot of walls and just some small corridor to crawl in. And yeah, that screen will take the maximum space, I would say. Will not be uh, optimized and compressed. But generally speaking, if you have a kind of normal screen, then you will have a lot of space and a lot of falling space. So basically, this is not optimum when you only have one space, or when you have two. Well, when you have two, it's the same. Let's say, for example, if I have two space, then it will take me 4-bit for the ID and another 4-bit for writing 2. And it's the same as writing 4-bit and 4-bit. Okay, so with two space, the compression doesn't help. With one space, the compression is actually worse because I have to write the ID and write 1 behind, whereas there's only one space, so I'm losing this 4-bit. But yeah, most of the time from 3, then it start to be compressed. Yeah. All right, so yeah, so this is the idea of compressing that. And of course, if I compress the data like that, then I will have to change the function that read this data to get an ID, right? So let's try to do that. Okay. First, I think I will write a macro just for us to help compacting the the idea. So okay, ID 1, ID 2, and I need to define. Well, I will just call it ID, and this is ID 1 that we will shift for 4-bit, and we combine it with the ID 2. All right, I hope my macro is okay. ID 1 or ID 2. And then let's combine this. Yeah, so maybe, yeah, I will replace my 255 by the correct ID, because I cannot pack 255 on 4-bit, of course. So it should be 15, right? Let's change that. Where it is? Sprite data. All right, so that should be 15. Right. Right. All right, and then, yeah, so then I need to pack first the count. So I said there was 11 here, and then the next one is this one. Oops, sorry. All right, so this. So 15, oh, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. So I will, so maybe I won't be lazy, just for us to have debugging. In the end, I will, when we will do the level editor, I will not use this enum. I will just write the number directly. But here for debugging, maybe it's easier to use the enum. All right, so I will do the compression only by lines, line by line, which means even if there is a space, if there is space at the end of one line and space at the beginning of the next line, I will not combine these two. So I still keep the two-dimensional array. I don't just convert it to one-dimensional array, just because it will be easier to I forgot the word. Sorry. To parse the to uncompress, to uncompress the data, to read the data actually, if you still keep one line per level. If you keep one line per line, I mean, if you don't compact in one dimensional array. And I think it won't save that much, probably not that much. You just, what you lose is maybe you have space at the end and you have space in the beginning, so you basically just lose two bytes because you repeat that space. So it's not, doesn't worth it actually. All right, let's continue this. So I'll copy that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I forgot to add the last ID. Okay, so if we have if we have less, I mean here for if we have an odd number of ID, then here we are losing this space. These 4 bytes are useless because they are at the end of the line. But that's okay. We still need to compress it for the algorithm the compression algorithm to work. All right. One, two. Platform. The leader platform. One, 2, 3, 4, 5, 6, 7. to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. So nothing. 3. So 1, 2, 3, 4, 5, 6, 7, 8. All right, 8. Okay. I will probably reduce the for the video reduce to just these two screen. I will not do the other one. I can comment that, and then when we'll develop the level editor, we can have back or full level. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 again. But I just realized something about. I'm wondering if two-dimensional array will. This is we cannot have a fix. We don't have a fixed length for the x anymore. And if those lines are of different length, I guess the compiler will align everything, or maybe it won't compile at all. So yeah, I'm not sure how we will compress that, how we'll do that. If we need one more direction, yeah, I'm not sure. We'll see. We may have to store every line in a separate array and then point on it for each line. Anyway, I don't know. We'll see. So how many lines I have done? So 1, 2, 3, 4, 5, 6, 7, 8. Okay, up to here. So this will comment it for now. 1, 2, 3, 4, 5, 6, 7, and 8. All right. Let's continue. Nothing for 3. Nothing for 3 again. for 3. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Again 14. Right. 2 more lines to go. 2. One. Okay, so that's the suboptimal case. And 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Right. So for example, this is the bottom line of the level, and that goes through 2 screens. Okay, on the bottom when you can go through the next screen. So yeah, that's quite good. Of course, if you have 255 empty space, then you have to do another space ID and then another number if it's greater than 255. Oh no, sorry, no, it's greater than 16. Okay, so this is the case here. We have 4-bit. So this I cannot do that. It's greater than 15 actually. So what should I do is 15, and then I should do nothing again. And 23 minus 15, it's 8. Right, so we have 25 nothing. Then we have again 8 nothing. Okay, this ID, so nothing for 2, and later nothing for 1. 2, 3, 4, 5, 6, 7, 7. So yeah, I should also fix this 14 is to, oh no, 14 is under 15. That's okay. Yeah, 14 is okay. Yeah, maximum is 15. ID, okay. Nothing for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then some more. And 3 more. And the last one is nothing. Okay. Last line. Nothing for 2. Two. 2. 2. 6 0. Nothing for 1. So here we have a 0, but we don't compress them. A series of 0, I mean. And this is nothing for 1, 2, 3, 4, 5. And then we have a 0. All right, so that's all compressed data. Let's check if that compile. I'm not sure. Okay, so what's the problem? As multidimensional array, blah blah blah. Maybe I should check declaration. Let's remove that. Does it compile it better? Yeah. I've bound a line, I guess. No, for all dimension except the first. Except the first. Yeah. Just have bounds for all dimension except the first. That's the opposite I should do. Yeah, I think so. I made a mistake. Obviously. Yeah, you need to do the one. Yeah, that's the high. Okay. Okay, I remove one line and just do that. Okay, so expression cannot be used as function. I need to probably add some too many initializer. 8. That's the opposite. Yeah, okay. Yeah, that's what I was afraid of, is if they don't have the same size, we need to have an array of pointer, I guess. And I'm not sure about the macro. What did I do wrong? It's not like that. You define a macro. I'll research a bit. So I hope it won't add too many code if we have an array of pointer. But we probably need to. I need to add some bracket around the variable of the macro, I think. Yeah, might be this one. Expression cannot be used as a function. Okay. All right. So for the array size, let's try to fix that first. Just want to see. How we did the init function. Put a pointer here. If we declare it like that, does it compile? Must be const. Bit in red, yeah. To put into read only section. Yeah. It's not const. It is const. So here we will fight a bit with the compiler. I think I will open the code I've done for the Arduboy project. Maybe that will help me to remind me the syntax. So that's the map data. Okay. Yeah, I had only one dimensional array. The ID was only one dimensional array. I'm checking the macro, by the way. Oh, okay. The macro one. So I was packing 3 IDs in for the Arduino project. Yeah, so that doesn't help me a lot. Okay, so this and this. I didn't even use bracket. That should work. Oh, maybe this is a space. Yeah, and that's a space here. No space. Ah, yeah, maybe no. It's okay. Okay, anyway. So, because packing in one dimensional array is quite difficult to manage after that. So, but I'm thinking maybe we cannot do otherwise. If what kind of syntax I could have? I can pack in one dimensional array and having another array for the index of the y. That could work also. If I don't want to count them. Yeah. This is quite annoying actually. I'm not sure which syntax I should use. What could work? Yeah, I'm really thinking if I should use one-dimensional array or not. I would prefer to avoid, but otherwise, because this line will have different length for sure, because of the compression. So if I put each line in one array and then having another array for the level that where each cells of the array point on the line, since the address is is an int, maybe that's quite takes some space, quite big. Obviously, that's more compact to have a one-dimensional array. To have one-dimensional array. Not this one. Let's try to compile first. Conflicting declaration. Really? Don't think so. Ah, I didn't save it. Yep. Okay, so now not in expansion of the macro. Maybe I did some error. Oh yeah, I forgot the comma here. It's I don't know which line. 200, 28, 28, 28. Here, here. All right, compile. All right, so after that, the rest of the code doesn't compile, of course. So we need to implement the logic to get the correct sprite ID from the data. But that works so far. So let's change that in the map manager. So do we have a function to get sprite ID? Probably not, huh? Yeah, so let's write it. So function to get a specific sprite. So we return a char. Get I guess it's a public one. Yeah, we can make it public. We'll see later. Get sprite. Get sprite. And I guess, well, it depends if it's an int or not. Let's see. Get level sprite add. Oh, okay, we already have that function. I thought we didn't add that, so maybe it's a private function. Get level sprite. Yeah, it's a private function. All right. So we don't need this one. Maybe we'll make it public if we need it, but all right, so let's change that. So to uncompress it, we need to count the sprite. So we need to go through the whole array and count the sprite. So that's why I wanted to at least go directly to the correct y and just iterate on the x. But yeah, okay, no, that's fine. Let's do the full count for now. To count, we probably need an int because we have a lot of sprite in the array, so we cannot avoid that, I think. So sprite add x. We also need to iterate on it. Let's hardcode some value for now. Maybe not. Can get the data, get it from the data. Well, it's not exactly that. Yeah. Now I should have size of the size of not this one, sorry. I'm checking if I have a size of somewhere else. No, I'm looking for map data. Yeah, this one. Yeah, probably can do a size of the level. Manager. Okay. Not sure about that, but anyway. So here to count the number of sprites, so if of sprite add x if it's nothing, then we will add the next number. Sprite data. No, it's in sprite data. Yeah, sprite data. Sorry. Yeah, what ID? Nothing. Can take this. So if we have the nothing idea, then the sprite index increase with the next one, but they are packed in. So it's not exactly that. I will fix it. Else. We just increase one. Here, the idea is to count how many sprites and until we reach the target. So I think we can write the target int target sprite index. Let's write it here. Map x time map y. No, it's not this one. Plus map x, sorry. It's map y times the number of the width of the whole map. So that should be this one. Level size x multiplied by the number of y plus the map x, and yeah, that give the target index, sprite index that we are looking for. Okay, get the index of the sprite in the one-dimensional array. And then we can, once we have it, we can search, iterate through the array to find the correct index. All right. All right. So, like I said, we have packed two index in one char. So let's use intermediate variable. Pack ID. Okay, I got this one. We can unpack them maybe. So we shift it on the right. And the second one, we mask it. Okay, that's ID1, ID2. So if the ID1 is nothing, then sprite index will increase with ID2. Otherwise, we increase it, but then we need to check ID2. 51. Okay, let's check ID2. So I write the algo quite naive now. We'll optimize later. I don't try to do something crazy. Check the first ID, check the second ID. Okay, if ID2 is nothing, then we have to yeah, we have to read for the next index. So maybe we can use Boolean variable for that. Bool read nothing count. False. Put it true here. And if ID2 is also not the space, so we increase that. Okay, go back to 1. If it's nothing, okay with that. Here, if we need to read nothing count, then the sprite index increase from the 1. Otherwise, sprite index just 1. Okay, that may work. And then we need to stop. So we need to stop. We need to stop every time we increase the index, I guess. So if sprite index is bigger than bigger than the target, or equal. If it's equal, okay, that's good. If it's bigger, because that means we are in between space, we read space. If it's bigger, if it's equal, anyway, break. I do it here also. All right, we break. So now let's say if it's equal, then we can return hey, actually we just want to return, so should not break. We can just do it here. I have a little bit of copy of code right now, I know, but like I said, just want to be quite naive now. So if it's equal, I return ID1. Else, if it's bigger, then I return nothing. Which I think can, yeah, okay, return nothing. Let's do the same here. ID2 or nothing. Okay, so now I can just remove that code. Here I was checking if the map was outside of the map, and yeah, I can keep that, I guess. I should keep that. Check if we're outside of that, not consider that collision. Okay. All right, and then let's say just to return something, we just, if we didn't find anything, we just return a collision. Return a collision. All right, so let's try if that compile now. Of course not. There's a lot of other access to level, but that could be fixed by calling the function now in Map Manager. Let's search all the access to level. So of course the access to the level is will be slower because we compress the data, but we have to really have to. So we should try to make the compression not too complicated to read. That's why I was thinking having just a one-dimension array is maybe a lot, because you have to iterate all. Right now the implementation, we have to iterate all the array before finding the correct place. But if we have a two-dimensional array or something to jump directly to the correct line, then you just have to iterate on the line to get the X correct. We will do that later, but right now I'm just trying to make it compile. All right, so level. Let me max case. All right, so this one in draw. Sure. The draw function also could be, right now I can just call the function, but it could be probably optimized by iterating also through the array, because we are still inside the map manager. So forgot the name of the function. Get level sprite. Yeah, it just give X and Y world, and probably I need to have a function that give X and Y on sprite level. Yeah. So that's fine. We can just split the function in two. Sprite level X, Y. Okay. Sprite level X plus camera X. Okay. I'm surprised that this is char here, but yeah, maybe it should be int also. We'll figure out later. They are all sprite. Max sprite, min sprite. It's a long time I didn't code that. I kind of forget. Let's figure out later. Get level sprite at x world, y world. So here we will make x map and y map. And I don't know how to call it differently. Okay, this one should be world coordinate. Okay. And let's split this function into here. So I just call the other function giving this into index of the sprite map and call the right function. And this become, okay, I should have renamed it map x and map y. Okay. Yes, but this function has changed. Now it's this one. This function becomes this one, so oops, sorry. I will replace it. Okay. So this one is the correct one, this one is the correct one, this one is okay. Yeah. Okay. So now I can call this one in the draw function. Here. X and Y. Okay, so in this draw function, so you see very suboptimal because I will ask the sprite, I need to ask the sprite on the left, etc. So that's why it's better to also iterate in the draw function. But right now there's let's just write it. Let's just call the function. So here, yep. And here's the same. X minus 1, Y. Okay. Do I access to the level? No. Should be okay. Let's try to compile. Forgot the semicolon. Where? Here. Here. Uh, 261. Here. Every application of size of yeah, probably. I don't know how to get the size of this array. That's the problem every time you have an array in ProgMem. I don't know how to get the size. I don't have that. Sprite data, for example. Yeah, I don't know. I have to search. That's how map size of no, it's not size of. I was checking this, but this is a ProgMem. A valid application of incomplete type. Doesn't know the size. Yeah. Probably need to go through a variable then. Let's declare a variable for that. Map data. Const unsigned int level size. Size of the level. How about that? does not, oh, I forgot the type, sorry. It's unsigned int. It's a const unsigned int. All right. So we have something to compile, and the size is 26,024, which means we saved some memory, but we have split our level in two. So the big question is, did we really save some memory? Of course, there is more code for uncompressing the data. So let's try and cross finger. I'm not sure we will see something. Yeah, and the frame rate is terrible, as you could imagine, and this is terrible also. All right, so but it seems to be consistent. So all right, so obviously there is some bug in the decompression algorithm or in the compression algorithm, but that's the idea. I think I will stop the stream here. Thank you for watching. And yeah, I think we will have to debug this and try to improve it. Try to make sure the frame rate is still okay, so that it's still fast to access the data. And but I think it's necessary. It's kind of necessary to compress a little bit the data. At least the packing of two ID on one chart. This is probably very necessary. And this if we only pack two ID on one chart, I could have kept the two-dimensional array actually, and that would have divided by the size of the map by 2 already. So adding the RLE compression of the space, yeah, obviously make it more save some data, but obviously increase the decompression algorithm. So this probably we have to test if it's worth it or not. All right, so I hope you enjoy this new stream, and then I see you in the next stream. Bye bye.